Water is an essential part of our lives. We need it to work, play, and survive. The impacts of climate change have created a significant challenge to traditional sources of fresh water across our planet, none more so than here in Western Australia. Rainfall and the subsequent runoff into our dams has decreased significantly, whilst the steady growth in our population has placed huge demand on other water sources such as groundwater. Western Australians have worked hard and addressed part of this challenge by being more water-wise, but we still need to secure stable, long-term drinking water supplies for Perth and beyond. At Water Corporation, we had to start thinking differently. As it turns out, we had a solution lapping on our doorstep all along, the Indian Ocean. This huge source of water runs right along our coastline, but obviously it's too salty to use in most applications, especially drinking water. To solve this problem, our salty seawater must undergo a complex system of simple processes to make it into a viable drinking water source, and that brings us here. This is a Southern Seawater Desalination Plant, one of Western Australia's large-scale seawater desalination plants located near Binningup. Water Corporation is at the forefront of desalination, having used the process since 2006. Collectively, our desalination plants have the capacity to supply almost half of Perth's drinking water, which makes them pretty essential to life here in Western Australia. As you've probably guessed, these plants convert salty seawater into drinkable, precious H2O. But how exactly does this process work? At the Southern Seawater Desalination Plant, there are 5 main stages: seawater intake, screening, ultrafiltration, reverse osmosis, and finally, water treatment. The journey starts 500 meters out to sea, with 2 8-meter-high intake towers. At this point, the ocean is 12 meters deep. The seawater flows via gravity through 2 2.4-meter-wide pipes to the wet well 10 meters below sea level, where we start the first process. The intake flow is very slow, which allows fish and marine life to easily swim away. The seawater then passes through screens that filter out seaweed and other ocean debris. Once the seawater has been screened, things get a little bit more high-tech. Introducing ultrafiltration. The ultrafiltration process involves pumping seawater through a series of filters like these. The filters consist of more than 7,000 tiny straws with holes that are 700 times smaller than a human hair. So small, in fact, they can reject viruses and bacteria. Now for the super high-tech section, reverse osmosis or RO. This part of the process requires extremely high pressure. Previously, we were at approximately 3 bar. We need to get the pressure up to 57 bar. How much is 57 bar? Well, it would push a column of water more than 570 meters vertically up into the air. Along with high-pressure pumps, we use regenerated pressure energy from the RO process to help generate the 57 bar. It all happens inside these energy recovery devices, which work by capturing the hydraulic energy from the high-pressure RO reject stream
and transfers this energy to the low-pressure seawater.
The seawater inside the rotor. The seawater leaves the device at high pressure and the RO reject at low pressure. If you're one of the small number of viewers that understood all that, congratulations. For the rest of us, it simply means we recover and reuse most of the energy in a very clever way. It's this device alone that makes desalination a viable option. Now that the pressure is high enough, the water can pass through the reverse osmosis racks. There are 16 RO racks in the plant, each with 244 vessels that contain 7 membranes. Each membrane is about 440 square feet and consists of layers that are spiral wound. So it's a little bit like a highly compact lasagna. This gives us the capacity to output around 305 million litres of water every day, or about 122 Olympic-sized swimming pools. Once the water has passed through the reverse osmosis process, we encounter a pretty unusual circumstance. The water flowing through here is almost 100% pure H2O, so pure that it's not suitable to drink just yet. Similar to the way we treat traditional water sources like groundwater, we need to treat the water with minerals and disinfect to stabilize it and make it safe for drinking. As with all aspects of the desalination process, the water is carefully monitored and the treatment levels are adjusted to ensure consistent water quality. The water quality monitoring and movement is undertaken by our specialist plant controllers. You can tell they're doing a very important job based on the number of screens they have in front of them. So now the water is clean, clear, and ready to drink, but how does it make its way to our taps? This is the main pipe where the drinking water leaves the plant and heads either directly into the integrated water supply or into dam storage for future use. Through Water Corporation's connected systems and to assist in ensuring water for all, desalinated seawater reaches as far away as Kalgoorlie. Desalination plants require a lot of resources such as energy, and we're committed to working with industry, government and the community to develop innovative ways to further minimize our environmental footprint. To make our desalination plants more sustainable, we partnered with energy suppliers to help offset our energy use. These partnerships resulted in the construction of large-scale wind and solar farms in Western Australia. We also continue to embrace new technology and efficiencies throughout the plant, such as the energy recovery devices. But we've gone beyond just renewable power sources and energy recovery devices to minimize our impact. We've really thought about the finer details too. Most of the plant was constructed on a disused limestone quarry. The layout was carefully designed to minimize native bush clearing, including the beautiful tuat trees. This means we can operate in harmony with our environment. We have regular visitors such as kangaroos, bandicoots, and a range of bird life including black cockatoos and blue fairy wrens. And the dedicated possum corridor allows our little furry neighbors safe passage through the area. We also have solar panels which power our administration building, but my favorite touch is cruising around the site under pure green pedal power. Desalination has certainly been a game changer for the future of our water supply, and there are plans to further increase the network. Does that mean we can take those long showers and flood our gardens with endless sprinkler hours? Absolutely not. Clean, fresh drinking water is a precious, limited resource, and we must treat it accordingly by being water-wise at all times. While we are confident that our water supply needs are secured well into the future, we must all look after our most precious resource today. To learn more about our water world, visit our website